Assalamu alaikum everyone. In this video, we are going to understand one of the most fundamental concepts in artificial intelligence, the neural network. But instead of jumping directly into deep learning or complicated architectures, we are going to start from the very beginning. What exactly is a neuron? Why do we need a neuron? And how does neuron takes input and provide output? And how does neural network actually learns? By the end of this video, you are actually understand the complete journey. Where the idea come from, what is biological neuron, what is artificial neuron, a single neuron calculation, activation function, and output from one neuron to a shallow neural network, forward propagation, backward propagation, weight updates, why this simple process matters the most in AI and deep learning. So first we talk about the short history from neuron to neural network. Biological inspiration, basically the brain process information through interconnected neurons. In 1943, Makello and Pitts proposed a mathematical model of an artificial neuron, and later work introduced multi-layer networks and efficient learning program. Today, the same basic idea remains: input with computation, activation, output, and then learning. What is a biological neuron? Dendrites receive signal from other neurons, cell body processes the incoming signal, axon carries the resulting signal onward. Just for example, when we touches, when our hand touches some hot thing, we will suddenly in shock and we will try to avoid these hot things from touching. So how the information goes from our hand to our brain, and then our brain provides the output to please stay away from that hot thing. So basically the neuron is the thing that calculates everything and provide the output signal to stay away from that hot thing. So, what is an artificial neuron and how it's work in deep learning in a mathematical way? So, we provide some input. For example, we have here inputs x1, x2, x3, and we also provide weights to each of the input like w1, w2, and w3, and we will provide a bias term that we need for the calculation of the neuron. So basically, in a single neuron, what actually the process happens? We will basically calculate the weighted sum of provided inputs and our weights plus biases. So in this neuron, first we calculate the z, and then we will provide an activation function on this output, and then we got a prediction, a result. So if you see the step one, compute the weighted sum, we will calculate the z from weight w, that basically important for the control of the input the information supplied to the neurons. Bias is the shift the neurons response, and z is pre-activation value produced before activation function. Suppose we have a w value 2, x value 3, and b bias is 1. So when we calculate the z, its value is around 7. Then we apply the activation function. Activation function transforms z into output of activation function and near to 1. So basically the neuron produce a value between 0 and 1. After applied sigmoid activation function, it introduced nonlinearity, allowing network to learn more than simpler linear relations. Produce the output. First we provide input, then we calculate z and apply activation function. In this case we applied sigmoid activation function, and we have a output. So that is basically a procedure to get an output. So for example, we got the value of a after applying activation function on z. Our value is 0.92. The model strongly leaning toward class A. So but one neuron has limited capacity to learn richer patterns. So we connected many neurons and provide a network that has input layer, hidden layer, and output layer. So if you see here, we have a four input inputs, and we have a three neurons in hidden layer. So if we see every single training example, or we say every single input example, are connected to each of the neurons in the hidden layer. Okay, so we will see is a fully connected neural network that is a bigger picture from the shallow neural network. So in this we provide some inputs to the neurons, and in hidden state Every neuron provide an A. Every neuron provide an A after computing Z and giving activation function. Then we use these three hidden neurons as an input of the output neurons. So in this output neurons, the calculations came from the hidden layers neurons. So here is a complete forward pass for layer 1. So layer 1 we compute a z, we call it a z1, and then we will go to provide activation function on this. Then in layer 2 we compute z, but we use, instead of x, we use a1 from the output of the layer 1 to compute z on the layer 2, and then we will provide an activation function and get the output. Information moves from input to output. This is forward propagation. Each layer takes previous layer's activation as an input, so then the output finally comes. Why do we need a loss function? Basically, we predict some and we have some true values. The prediction alone does not tell us whether the network is good or not. So we will compute a loss function that measures how far the prediction is from the correct answer. So in this case, for binary classification, we use binary cross entropy function that is given in there. Learning starts from backpropagation, like after computing loss, we will then compute the gradients and then we update the weight accordingly. Backpropagation works backward through the network. It uses chain rule to compute how much each weight and bias computed in the loss. Then the result is a gradient direction in which loss changes. So we will basically calculate the loss, and each weight and bias contribution. We will compute the loss function, derivative loss function with respect to W's and with respect to B biases. Update the weights and biases. So here is the formula that we use for updating weights and biases. The new weights is equal to old weights minus alpha is our learning rate, how much step we will move forward in the learning process, and then the computation computed gradient, and we will have the new weights, and exactly same procedure for the bias. Alpha is a learning rate. If the gradient is positive, the parameter move downward. If the gradient is negative, parameter moves downward. The goal is to reduce loss over repeated updates. Here is a learning loop for a neural network. First step is to provide input data. Then we will have the forward propagation. In forward propagation, we will calculate some z and we applied activation functions. And then in step 3, we have some predictions. After that, we compute the loss through binary cross entropy or another loss function if needed. Then we will go to backward propagation. Then we will update weights and biases. And this process repeated until and unless we got the perfect learning neural network. A small neural network example, basically, suppose we have x, value of x, weights and biases. Step 1, we compute z, that is around 0.5. Then we applied a sigmoid function that is around 0.622. Suppose the true label y is 1, so the prediction is reasonable but not perfect, so the loss is greater than 0. So in backpropagate we calculate gradient and updates the value. Then if we go to the next, why these simple neural networks matter? It teaches the fundamental units of modern neural networks, the neuron. It shows exactly what learning means. Parameters are adjusted to reduce error. Forward propagation answers what does network predicts. Loss answers how wrong is the prediction. Backward propagation answers how should each parameter change. Weights update answer how do we improve the next prediction. Deep learning scale this same core idea across many layers and many parameters to make the complex patterns. What is the purpose of training? So basically our goal is to learn W and B that maps the input and provide the useful information. Our basically the purpose of training this neural network to make some predictions that are very near to the actual values. Before training, weights are usually unhelpful or random. We choose random weights. During training, prediction are compared with targets. Loss creates a learning signal. Propagation distributes that signal to the parameter. Repeated updates gradually make the network better at training tasks. After training, the learned parameter are used to make prediction on the new data, on the raw data. If you see in the bigger picture, we have x, provide some weights, compute z, then activation function, we got some prediction, we compute loss, we basically backpropagate, compute gradients and updates. One neuron give us the basic computation, many neurons from layers from a neural network, forward propagation produce prediction, loss measures error, backward propagation compute gradient, and basically gradients updates. So the key takeaways from this lecture: a neuron basically computes Z, an activation function transforms Z into an activation, a neural network connects many neurons into a layer, forward propagation produce a prediction, loss function measures prediction errors, back propagation calculates gradients, gradient descent updates weights and biases. Repeating the loop is how the network learns. This simple mechanism is the foundation of deep learning. From one neuron to deep learning, the mathematics stays simple. What changes is the scale. If we want a big prediction, so we have to train the complex neural network that has many hidden layers, and we will get the answer after that.